everybody, and welcome to this talk from two folks associated with Kaskada. It's about security against bot attacks, something we're all super worried about, all kinds of security threats. And this, what? No, the talk isn't about that. I am sorry. See what I mean? Dork. It's about creating and operating machine learning models using feature stores and feature endings. And what Kaskada does is special. I went to your website. Is this an accurate? Are you working? Yeah.
Kaskada we build a feature engine with time travel.
Okay. All right. So we have Dr. Charna Parkey. We have Davor Bonaci. They both work for Kaskada. I am going to leave now, kind of. And they've expressed interest in having your questions as they go along, so you can post them in Q&A. Thank you very much, and take it away.
Thank you so much. All right, let me share my screen. All right. And actually, there we go. All right, Davor, are you ready?
I am ready. Take it away.
All right. So I would like to actually begin with a story. It's a time in my career when I had just transitioned from an individual contributor and a data scientist to a business leader and a stakeholder. And I had a team of data scientists to help me solve a retention problem using machine learning, which was super exciting. We began with interviews, and here's what we had looked at the time. I was hopeful. The team of data scientists were doing the right thing, understanding where we look today, getting to understand the business. We had things like renewal dates, product offerings, budgets, and active users. And they'd interviewed me and my team, as well as the sales folks and others, about what actually was going to help predict renewal. But it ended with them coming back to me to say, well, monthly active users is all we can give you. The data just isn't there. Well, it is, but it isn't. We can't reconstruct history. We have click streams, error logs, and session logs, but we can't actually stitch it all together to make a prediction. So don't worry. They told me we have prioritized building a new data pipeline, and next year, once we get the data collecting, maybe we'll have enough. But these stories always end this way. I wish we could have known what we know now when we started. I wish we could build a time machine to go back and tell our past selves what we needed to know, to collect the right data at the right points in time so we could have solved your problem. But the reality is, just like with Marty McFly in Back to the Future, erasing your lessons learned by preventing the lessons in the first place isn't the goal. If you collected the right data at the right points in time to solve this one problem, you wouldn't be able to solve more problems as they arise. So, some companies today have been able to build models from event-based data, and they've realized a large impact on the business. Companies like Amazon and Netflix, who with a team of data and infrastructure engineers did build a limited version of a time machine for their data scientists, have saw these impacts. But you don't need to just trust my individual story, right? We know that other data scientists have found success from leveraging the temporal relationship of event-based data. And there is a reason why we're talking about this now. The time is now to make a shift. Your teams are swamped. You're having to maintain the models that you or someone else on your team has built in the past, and also trying to keep up with solving new problems. Today, on average, it's taking 7 to 12 months to deploy models into production, let alone update them. And you can't afford not to have an iterative process instantly. But here's the thing. Instant iteration when making models directly from event-based data requires a few things for data scientists to actually make this work. You need historical feature value generation to try new features. You're going to need some sort of expressive time selection so that you can specify not just your features, but your model context iteratively. And then you're going to have to be able to join values between different entities at precise points in time without leaking information about the future into your training data sets. And then the last point here, we're going to have to be able to share those feature definitions to power live models. Because if we don't, we can't actually make sure that the models that we trained are working in production in a tight iteration loop. So something needs to change. And you're already able to create models from historical data today. But in the past, without event-based data, you would have created a training data set and attempted to use just that data to iterate on just the features. Maybe, things like computing importance across various segments of your data. But to be able to create models from event-based data instantly requires a shift in your workflow. Davor and I are going to do a bit of role-playing in roles we've both been in the past to illustrate. So here we are. We're trying to solve that customer retention problem. And this is the data for the model that we want to build. Our CSMs have told us renewal date, the products and when they ship, the type of budget that's involved, and of course, whether or not the users are active in our product are important and are likely to be predictive of success. So, hey Davor, I'll need access to this data for all of our previous customers. Can you give me access to the sources themselves?
Well, maybe. Can you maybe tell me exactly what might be important? Because this data likely spans several of our systems, right? We likely have this data loaded in the data warehouse. Have you tried using that? Maybe the existing data in data warehouse can help you, and maybe some of these features that you may be interested in already exist in our feature store. So maybe start there.
Well, see, if I start with what we already have, that may not work. So let me explain a little more. I have an idea of what features might be predictive from talking to our CSMs, but not when they might be predictive. And so the situation is that they need a prediction as soon as possible, and I need to be able to test several different points in time along the way.
Well, if we need things to do something at different points in time, can we just kind of write some pipeline that does something every month? So we run this pipeline monthly, and then over time you get the data you need.
I mean, I don't know. Maybe it could work. Let's try it and see.
All right.
So let's more precisely define our goal. Customer retention involves accounts and subscriptions. On the slide, you see 3 accounts, Panda, Owl, and Marmot. And each account had a number of subscriptions over time. Panda subscribes in 2016, although they churn in early 2017, and then they resubscribe in 2018. And every account has a different start and end date. But they also last for different periods of time. The prediction time is when our model is going to actually make the prediction. Maybe it's 6 months into the subscription, maybe it's at the midpoint. But let's say our goal is to predict contract renewals at the midpoint. That'll leave enough time to save the account. The label time, though, is when the actual subscription is over. So when the subscription started, we have a subscription event that has a start date and an end date. So our end date is obviously when the decision or the account label is known. So that's our label time. The entity column here is those actual Panda, Owl, and Marmot values. And then just for an example, count sessions is a possible feature. And the label column, of course, is what the actual label is. Did they churn? Did they not churn? So you can kind of see where I'm going here. One key shift in your workflow comes with how you think about feature engineering. in the past, without event-based data, you would have gone to your data engineer like Davor to gain access to pre-aggregated data pipelines. Or maybe run a series of SQL queries yourself to pull event data from specific time ranges and manually build this data set. But if you're going to build and operate directly off of event-based data that allows you to iterate on a second aspect of your workflow, you're going to need a little bit more in the model context, or in this case, time selection. So this is a complex problem, and we're going to build up our understanding of it as we go. So don't worry about all of the specifics until we get to them. We'll definitely cover that. So let's suppose, however, Davor can get me access to the data I had asked for, the points and times I had just asked for, and he's able to run a backfill job to get me that data set. And he's super proud, and he brings it to me.
I think, here you go. Here's what I did. I pulled out the transaction data. I've used Spark to create a set of queries and got the data prepared. I had to construct subscription lifespan a bit by hand because I had to find kind of the beginning and the end. It wasn't super easy to kind of group those transactions together. I was able to drop some of the records that weren't relevant, and then I had to stitch something manually together. But I do think this solves what you needed.
This is awesome. Thank you so much. But wait, I'm looking at these columns, and I realize that the entities show up multiple times in the training data. Is it possible that what is predictive for first? Yeah. So can I have that time column back? Like if you're going to have multiple training examples per entity in here, can you put that time column back in there?
Well, sure, maybe. It's not easy to put a time column back because of how I stitched these kind of subscriptions together from individual events. Mm-hmm. So some kind of different grouping and shuffling is needed and searching within a subscription. So sure, but it's kind of at least a week, if not a few weeks before we can have that. Yeah,
it's pretty important. So if we could add the time column, or maybe a label of like if this is the first or second subscription, anything like that would be super useful.
All right.
Having had a lot of conversations with customers and users while we built Kaskada, we've learned that there are a few problems here that we've just illustrated that you're going to hit along the way if you want to make this process truly iterative. So I'm going to put some pseudocode on the screen and talk a little bit through some of these lessons. When you're creating models directly from event-based data to preserve your ability to iterate and not spend weeks and months going back and forth, you'll need to define not just how to compute the predictor features, but also how to compute the target feature, and then when to compute them, the prediction time and the label time. That way, you'll instantly be able to compute the predictors and targets at the right points in time instantly. So if we do this, we can compute the prediction times in order over time for each entity, and then compute the label times when they are correct, and output the labels at those points in time. So you can see that this data set was computed for all entities, for all subscriptions. And the feature values can be used now for model training. But you'll notice that these examples are including all subscriptions, similar to what Davor had said from a single entity. Panda had 2 and Marmot had 2. And so the challenge with only specifying prediction time based upon the start date or the end date is that you need a little bit more time specification. So Davor comes back and he's figured out how to give me a data set with the features computed for only that first time customer subscription. And so
here you go, right? So you wanted kind of to limit the first subscription only, and I found an easier way to do it, right? So I can group the group by key. I can group by the user, and then do a search within this key for the first unsubscribe event, and then I do filtering of all events beyond that unsubscribe event. So now we have the data set that limits, it's filtered only for each entity for their first subscription. So here you go.
Well, this looks good, but the thing is, I'm not sure at what point during the subscription will be the most predictive. You've computed this monthly, but actually, I don't know if it'll work. And the second thing, I'm so sorry, I just realized that the subscription end date that you used for labeling that data set isn't when our accounting team closes the books. Can you relabel this data set 15 days after the subscription ends?
I mean, sure, it's possible, but like, I built quite a few things already. Like, are you sure you know what you want? Right? Are we sure this is it now?
I'm sure I need it. I can't promise you that's all I need.
All right, we'll add it to our work log, and we will deliver this, a couple of weeks away from now.
Okay, thank you. So, operating on the resulting data from a feature store or a data pre-processing pipeline isn't enough. You'll need to be able to recompute the same features at different points in time to see if your model would be more predictive at the time of an event and not just 6 months after our customer begins their journey. Key moments for prediction and labeling may be different. Let's take a few examples. So I changed this prediction time to be first, like Davor had done for me with his data pipeline. But I noticed a few other things. Somewhere in my investigation, I noticed that the first-time customer renewals are more important, and I need to be able to test this theory with a different label time. Often, for retention, the onboarding experience is very important, and the features that I compute are going to be different. They may never get to fully utilizing the product in the first year, and maybe the partnership and continuous growth is more important. So, your training examples can be instantly recomputed if you expose these iterations to the data science team. But now we have no negative examples to learn from. So if you try changing the label time to be 15 days after the subscription end date, like we had talked about before, you're going to get a different result. And you can test it immediately. But you can also add a data-dependent condition on which events to include with your time selection. The thing is, these types of business logic change over time. And when you find that this is going to change not once, but not twice, but maybe every quarter, maybe every time you change your pricing model, it becomes untenable for your engineering team. So, here's where you can get even more gold out of your data. Davor, I have an idea. Our customers don't live in a vacuum. What if, now, just hold on a minute. What if we know that if our executive sponsor leaves the company, or if the earnings report for the quarter was bad, it doesn't matter if they're seeing success with our product. Transactions don't matter. They need to churn anyway. And so if we were able to know that something bad was happening to the company's revenue, or if someone changed jobs, then we could reach out and do something different. We could get a new point of contact. So if I wanted to join information to that transaction data that you built for me, maybe from Salesforce or like stock market data, what would that take?
Well, these are new data sources. We probably want to take the first step to put it in a data warehouse and keep it up to date so we can do different things with it. So sure, it's something that we can collect and maintain in a data warehouse, going forwards.
but I need it for the, what if I bought a data source and I gave that to you? Could you join those two together?
I mean, sure. Like, if we put it, the data set that you buy, if we put it in a data warehouse, like we have the SQL interface on top of a data warehouse, like SQL has some joins, inner joins, outer joins, different types of joins. I'm sure you can figure something out.
Maybe, but my experience with SQL says that if I I need to make a training data set. So if I wanted to get the stock market data joined historically to my transactions, I don't know if SQL can support me there. Am I going to have to manually label it, or is there a thing that you can build in an automated way?
I mean, sounds like you're looking for a temporally correct join that is looking up the value of a changing variable at different times. I mean, it's not an easy thing to do, but like it's generally doable. Maybe I would approach it by maybe writing a pipeline that processes this data kind of in order, and then maybe I would look up for every event what was the value at the time, and then enrich the event, and then restore it as kind of enriched events, and then maybe you can process those enriched events. And so if we kind of double, triple the amount of data that we store and make every event enriched, maybe that's a way forward.
I mean, it sounds like a good way forward. Can you do that?
I mean, it's possible, but given that we have to write new pipelines, organize data, get new things, like we are definitely talking here more than a month. Maybe in 2 months we can have something like this done.
Yeah. Well, okay. So if you go build that pipeline, and then I'll do the hand labeled data set this once to make sure it's important, and then we'll have it for the future. That would be great, though. You go do that. I'll see what I can get.
All right.
All right. So the thing is, Kaskada built a time machine for future engineering, and we've learned a lot of lessons from that. So we've had this conversation before. I laugh because the engineers had made a series of simplifying assumptions trying to optimize computation, that the customers themselves would be able to join their data before they got to us, and boy, were they wrong. Thankfully, we caught it in time. So this is something you need to consider as well. So to preserve that tight iteration loop that we need, and to prevent leakage so that you don't know about the future before you should, you can't do things like trim the time resolution to try and line up those records. You need to actually have a temporally correct lookup. And those temporally accurate joins from one entity to another is the difference between being able to find gold in a set of event-based data and being able to look across all of our event-based data. Because as part of your iteration, you're going to find, or you may find, especially for customer retention, that you can't find the set of features that are predictive, or that your data set is too small based on the entity you selected to make an accurate prediction. So in this case, in the customer retention case, if we want to look up the budget of a company onto a member event, it's important that this information is accurate in the past. And so, you can do this by hand once, maybe you can do it by hand twice, but when you're trying to join all of the external data, it becomes nearly impossible without a system. And to have a more complete picture of the changing environment that may be impacting the outcome, it's necessary. Many people have not been able to find predictive features because the data that they're looking at isn't the only thing impacting their customers. So feature values need to be calculated and joined in order. And joining with the contents of a relational database that reflects the current values and not the values of the relevant times in the past is not enough. And so you need native time travel, not just a feature store. So part of the solution is a feature store, but native time travel in your feature engine means that creating models from event-based data can bring that power of iteration to your workflow. You kind of solve from our interactions. It's 2 weeks here, 3 weeks there, 2 months here, etc. And it's a domain-specific problem. So if you're able to solve for these 3 key components, you can go from 7 to 12 months of getting into a model into production into a tighter iteration loop. And you won't need to know the right data to collect at the right points in time before you've had a chance to learn what's important when. Native time travel in feature engineering solves historical feature value generation instantly, flexible time selection, temporal joins, but also one more piece that we're about to talk about next, getting into production. So Davor, guess what? I have solved the retention problem. You gave me the perfect data. I found the features. I know what's predictive, and I want to get to production. Can you help?
All right, that's awesome. I love getting things to production. So let's see your feature list that we need to put to production. So the first one says here, percent utilization. Like, can you tell me a little bit more about that?
Yes, absolutely. So here's the thing. With our product, if people are using it as much as they can, so let's say they're writing a document and they write 2 documents, but they should be writing 150, 2 out of 150 is not great. But if you wrote 2 out of 2, that's 100%. I want to make sure that, relative to what they should be doing, that percent utilization has a good denominator here.
Oh, I see. So it sounds like we are kind of counting something and counting another things and dividing by something. Okay, so sounds like a mean operation of some kind. Sure, that can be certainly built. Your second feature seems like counting engaged users in a time window. So kind of what does it mean for the user to be engaged?
Yeah, so I found a feature that I wrote that has this special math. And so we have these session tables and we have the edits on the documents. And so what we're going to do is if a person has made an edit within a session window, but not more than 5 minutes have passed, then we count that as being engaged. And then if they're engaged for a long enough period of time, we call that an engaged user.
All right, sounds like a quite complicated logic to define what does it mean to be engaged user. Tell me a little bit more about this window of 30 days. What kind of precision, resolution? Is this a sliding window? Is this a calendar month? Tell me a little bit about this 30 days that needs to be done.
Right. So if you think about when the model's going to make the prediction, I'm trying to get this information to the CSMs, before they get on a call with customers. So ideally, this would be sliding. So for the very last 30 days, or at least the last 30 business days, that would be great.
And what kind of latency? Can we run this monthly, or we need to have a low latency?
No, monthly wouldn't work because, so the customers start on different days, and so their check-in points are in different days. We don't align. It's impossible for a CSM to get on the phone with 50 accounts on the same day, so we stagger that across the month. So we could do this nightly, but no less frequently than nightly.
I see. So sounds like I have to run some kind of periodic job that is looking always for the last 30 days and counting different things. I mean, there are production systems that can do that, but that has to be written and automated and maintained. All right, so looking at these other things, they look at similar patterns, but a few different patterns. All right, so and from few different data sets that need to be joined. So yeah, sounds like this can be built, certainly. Again, this is something like on the order of a month, maybe 2, to get all of this done, productionized, the code is put to production. And until you have it populated in a feature store, this sounds like a month or 2. Maybe more reasonable.
It's okay. So let me explain what I'm dealing with here, because by the time you do this, I'm not sure the model is still going to be predictive. So here's the thing. We continue, you know this, you're on the engineering team. We have a continuous set of feature release every single day. Well, I mean, at least once a week. And then we launch products every 9 months. And I won't even know at that point what feature we'll need to make sure that the model is still predictive. And so if every time I ask you to get this model to production takes 2 months, I don't see it. And in the customer retention case in particular, right, we're trying to save these accounts and it's changing on a quarterly basis. And so the more product that we're making, like the more usage you need. And I don't know what we're going to build next. So I don't see how this is tenable, not to even mention the drift in the data. So is there any way that you can do this faster?
I mean, right now in the current situation, probably not. I mean, I understand that drift happens and that product may change in the coming weeks and that new features, new feature definitions need to be updated. But right, like given the situation and what needs to be built, like we can't do it, just can't be done faster.
Yeah.
Probably the long-term solution sounds like that we need a system that will more or less automatically move these features from training to production, right? Like, sounds like, you know, you've already built these features because you presumably built a training data set. So if we can move these features automatically from training to production without any other input, that seems like the way to go, because like whenever you train a model, you know, on a click of a button, they can be available in the production environment. And so that sounds like the, you know, long-term solution for what we need.
Yeah, that makes sense. I guess, you know, if we start here, maybe we can go from there. We'll put this one in production and maybe we can speed up in the future.
I mean, all right. To do that, we need likely an investment in some kind of, you know, distributed systems platform that can take event-based data and then can serve it in two different ways for historical feature values for training, and then take those feature definition and move it to production. We likely need some kind of views on the features you select that can be called via APIs, right? Like that certainly can be built, but it's not a simple thing, right? To be able to serve those two different use cases and quick iteration. But it certainly can be done. It seems like something we need to do. If you're interested, obviously Kaskada has been working hard on systems like this. If you're interested in the internals of a system that can serve both historical feature values and current feature values, tomorrow's session at 10:15 will go into the data engineering and system builders perspective in how to build a system. But kind of from the architectural point of view, we really, to solve this problem, we likely want to have feature generation system that likely is separate from feature serving system. So we likely want to create a feature store, kind of like a cache of features between feature generation and feature serving. Redis sounds like a good solution to do that, as a cache, as a feature store that can kind of do really low latency serving, and that we can reliably populate. It can have kind of high reliability for serving. So that sounds like a good choice in an overall system architecture of the whole system. So, you know, if we build something along these lines, seems like long term we can have a success.
Yeah. So the key takeaways here for me, from a data science perspective, to succeed, you need these things as a data scientist, and you need to ask for them from your data platform teams. The thing is event-based data is special. It has a temporal component to it. And to compute features directly from event-based data, you'll either need to take into account when you build the system yourself, or you're going to have to find one. The iteration, as we talked about, for customer retention is key, but it's also key in other scenarios where the context around what you're trying to predict is changing, the environment is changing, or the data itself is changing very quickly.
And to actually get the results, to actually move business KPIs, we need models to run in production. And for that, we need either kind of dedicated production pipelines. We need to find a way to eliminate discrepancies in production. And the way to solve it automatically is through feature engines and the feature store. And so I think the key takeaway that we want to drive here is, right, as you saw in the exchanges between Charna and me today, to get to success without a system like a feature engine and a feature store, it's really hard. But the systems are now becoming available that are built for machine learning, that are built for event-based data that can help you solve these problems. You don't need to build bespoke solutions, and you can, get these types of systems off the shelf that can help you focus on your business logic, on your data, on your kind of company-specific features, and you can start building models that actually work, and do that in days or weeks at worst. And Kaskada has built one such system that shines on event-based data, that shines for these types of predictive models. But other companies are there too, that can help you with other types of data, with other types of use cases. And our point of view is that it's definitely time to start looking at systems like this and solve and focus on your problem at hand, and not go build very low-level platforms that are somewhat generic. So if you're interested in learning more, please visit our booth. And if you're interested in kind of the builder's perspective and data engineering perspective to our system, please join us tomorrow when Ryan and Michael will be sharing more about how our system works from the internal perspective. Thank you so much.
Thank you. Let me see if I can stop sharing so we can take questions. I have found my screen. Huzzah! Let's take a look at the Q&A tab.
That's my question, and I was wondering about other applications. You seem to be talking about fintech. What else could you do with event-based data?
Yeah, for sure. So there's as a data scientist in the past, I'll take this one and then pass it to Davor. So in fintech, in particular, fraud models are important, but also money laundering schemes, things where there's regulation that says that you can only use features to trigger fraud or money laundering investigations around when someone goes outside of their typical behavior. And so that definition of typical behavior needs to be localized to that point in time. And so that temporal change matters, as well as the adversarial environment that you're in. Gaming is a very key area for this. So gaming companies are introducing systems that are called live ops that let them actually change the game environment around a player while they're playing. So who gets to see a level up, who gets to try and buy an in-app purchase is different across their entire customer base. And so if you're trying to engage players, you're going to want to look at the events. So it's more than segmentation. You need to be able to get to behavioral segmentation and then delivery of event-based messages and then customization of event-based messages. But also, I think recommendation engines and forecasting models. Davor, did I forget any?
No, I think that's great.
Okay.
Any other questions out there? Okay, well, I really appreciate your time. Hearing you, I want to cut anyone off. I think I'll be co-hosting your session tomorrow. I have to check, but if it's an emerging tech, I will. So I'll see you again. Actually, I'll be a little more behind the scenes for that. Everybody who is here, there'll be a feedback form in the chat for you to fill out. We'd appreciate that. And again, we really do appreciate your time today. Thank you for being here. Have a great evening. Hope to see you again tomorrow.
Thank you all.
Thank you.
It's been a wonderful conference, and I've appreciated all of the talks so far. So do reach out. I'm on social. Davor is on social. You can tweet at us. We'll see you soon.
Okay, thanks. Bye-bye now.
Bye.